Right. Today I'm going to do a question about buffer solutions. And it's a very long question, and it's worth 16 marks, so a lot of students do struggle in these sort of questions. So you start by reading the question. It says 0.210 molybdenum cube solution of potassium hydroxide was added from a burette to 25 centimeters of 0.1 molybdenum cube solution of ethanoic acid. Given that the value of acid dissociation constant Ka for ethanoic acid is 1.74 times 10 minus 5, calculate the pH of this solution in conical flask at the following points. So before any potassium hydroxide added, after 8 centimeters of potassium hydroxide added, and after 40 centimeters of potassium hydroxide added. I think the first thing you do at the beginning of this is say before. So just do before any potassium hydroxide added. Okay, so the first thing you do is say, right, so if I want to know just the pH of my weak acid, I can use the acid dissociation constant for weak acids. Ka equals to CH3COO minus H plus divided by CH3COOH. So you rearrange this equation. So you change this first of all, because it's a weak acid, to H plus squared, because they're both the same amount. So you can represent like that, divided by the weak acid, concentration of weak acid. So then if you rearrange this, you end up with H plus, concentration of H plus ions equals to the root of Ka times concentration of your acid. Now, H plus ion concentration equals to Ka, which is 1.74 times 10 to minus 5, times the concentration of your weak acid, which is 0.160. So the H plus ions concentration is going to be 1.67 times 10 to minus 3 molybdenum cube. So now you can just minus log there, minus log of this value, which gives you 2.78. So the pH equals to 2.78. So that's the answer, the first point. Now we're going to work out in the second point. So after 8 centimeters cube of sodium hydroxide, potassium hydroxide added. So what we do first, we work out the moles of potassium hydroxide or hydroxide ion solution, and which will give you 0.210 times 8 divided by 1000, which will give you equals to 4. This is 4 times 10 minus 3 moles of potassium hydroxide present. Now the original moles of acid is going to equal to 0.16 times 25 divided by 1000, which equals to no, that's incorrect. So this one here, 0.2 times 8 times divided by gives you equals to 1.68 times 10 minus 3, and that one gives you 4 times 10 minus 3 moles. Now the moles of acid left equals to 4 times 10 minus 3 minus 1.68 times 10. So that's the moles of the sodium hydroxide and moles of your salt, which is formed. So B equals to 2.32 times 10 minus 3. So also I forgot to say is that moles of salt, which is this, formed is equals to the same as the potassium hydroxide ions. Okay, now you plug this in the equation. So you can plug this in the equation. So you got H plus ions. So you got the buffer calculation equation equals to Ka times your concentration of your acid divided by concentration of your salt. Okay. So the H plus concentration of H plus ions equals 1.74 times 2.32 times 10 minus 3 divided by 1.68 times 10 minus 3. So that's has to be divided by volume because it's concentration of. So this will give you equal hydrogen concentration ions present after 8 centimeters cubed. It's going to be 2.4 times 10 minus 5 mole per dm cube. Okay, the pH equals to minus log of that, which is 4.62 for second point. Now the third point is when you add 40 centimeters of potassium hydroxide. Which is going to be, okay, after adding 40 centimeters of potassium hydroxide, you end up with this sort of calculation. So you've got to work out moles of potassium hydroxide, which is 0.21 times 40 divided by 1,000, which is 8.4 times 10 minus 3 moles. So then you want to know, because you react the sodium hydroxide with your acid, so excess, wherever is left, excess potassium hydroxide will be 8.4 times 10 minus 3 minus 4 times 10 minus 3, which is moles of your acid, and they'll give you equal to 4.4 times 10 minus 3 moles. Okay, so that's moles of potassium hydroxide, and also is moles of hydroxide ions. Okay, so equals to moles of salt. All right, then you have to use Kw equals to H plus times OH minus ions concentration. So if you rearrange this equation, you end up with H plus equals to 1 times 10 minus 14, which is Kw, divide the concentration of sodium hydroxide, which is 0. Oh, we haven't worked out concentration of sodium hydroxide, do we? So the concentration of sodium hydroxide, we need to work out here. So concentration of sodium hydroxide or hydroxide ions equals to 4.4 times 10 minus 3 times 1,000 divided by 65, which is equals to 0.0677 mole per dm cube. Okay, now we can plug that in here, which could be 0.067, which is going to be equal to 1.477 times 10 minus 13 concentration of that of hydrogen. So pH is going to be equals to 12.83. That's how you answer this whole big question. Hope you understood. If you got any questions, please, you can email me or you can send me a message, and I will try to explain to you again if you got difficulties. But I hope, you know, that it makes sense, that what you're doing. Thanks. Bye-bye.